Okay, today we're going to go over completing the square. Yesterday we were comparing standard, factored, and vertex form, right? This is our standard form, this is our vertex form, this is our factored form. There's different methods to move between the three forms. They're all representing the same quadratic equation, they just look different, you could say. We know that to go from vertex to standard or from factor to standard, we are going to expand. Okay, expand and simplify technically, but we'll just short form it. We'll say we expand the equation. Okay, to go from standard to factored, we factor. And finally, to go from standard to vertex is exactly what we're doing today. It's called completing the square. Okay, now this process, once we've done today's, we'll actually know how to move between all of them. We'll know how to move from vertex to standard, factor to standard, standard to vertex, standard to factored, and which means you can essentially go from any equation to any other equation, okay? Today's lesson, completing the square, is a little difficult, so I need you guys to focus for this one. What form are we in right now? Standard. Good. I'm glad you recognize that. We're going to take our standard form and we're going to change it into a vertex form. Okay? I'm going to write the original standard equation above. So y is equal to usually ax squared plus bx plus c. Okay? So, the very first thing we need to do is you need to recognize what the a value is in our equation. What is the a value in our equation? 1. That's right, it's 1. So in completing the square, what we want to do is we want to take that a value and divide the first two terms in the trinomial by the a. So what we mean by that is our x squared and our b term. We're going to divide both of them by our a. Okay? So that's pretty simple in this one because a is a very easy number to do division by. We're going to divide both of them by 1. Now, when we divide by 1, we're not actually getting rid of the 1. It's the common factor to the first two. So it's going to come to the outside of the brackets. And then we're going to set up a pair of brackets. So essentially what we've just done is we've used the a term to common factor these two numbers. Okay? So when I divide them both by 1, there is no change to them. The 1 is on the outside. We have x squared plus 4x. And we end with another bracket there because we're going to be working with the new number inside. Now, I call this our new number, our new b. If a had been another number other than 1, then this would change when we divide it by something. Okay? In this case, it didn't. This term here is our new b term. Okay? There's a little side equation I need you guys to get used to. b divided by 2 squared. Okay? Our new b term is going to be put through that equation, and we're going to use the answers to that to go back into this. So, our b term is 4. We're going to take 4 and divide it by 2, and then square it. What's 4 divided by 2? Squared? Good. This 4, we're going to take the positive and negative value of it and plug it back into this equation. I'm going to explain why we do that in a sec. So we have y is equal to, the 1 still stays outside, we have x squared plus 4x. And this time we're going to add and subtract 4 inside the brackets. Now, when I add and subtract 4, what am I essentially doing here? What is 4 plus negative 4? 0. So all I'm doing is adding a 0 to this equation, which means I'm not changing anything because I'm adding and subtracting the same number. That's what allows us to do this. From there, we're going to take the negative value. So we had positive and negative 4 inside the brackets. We're going to take this negative value and bring it outside of the brackets. When we do that, we have to multiply by our a term. Think of distributive property. Because of BEDMAS, if I'm to just take this out of the bracket, technically the first thing I need you to do is distribute this 1 to all of the terms. Okay? So when we take the negative term, we always take the negative term and bring it to the outside. We need to multiply by our a value. Well, our a value in this case is just the number 1. So we're going to take negative 4 times 1. So our next line is going to read y is equal to, the 1 stays the same. Our bracket will now only have 3 terms, so a trinomial. 4x plus 4. Negative 4 times 1 is what? Negative 4. So we're left with negative 4 outside of the brackets, and we still have positive 16. Now, this is the important part. The reason we did all of this, what we've just done is created a perfect square trinomial. Okay? That's what this whole process is trying to do. We're creating a perfect square trinomial. And if you don't remember what that is, I'm going to show you how to factor this the long way, and then we're going to go back to a shortcut to this. So, what we're going to focus on now is we're actually going to factor the term inside the brackets. Like I said, this is a perfect square trinomial. So we'll factor this the way we're used to factoring, where we take the factors of the first term, which are going to be 1x and 1x, and the factors of the last term are 1 and 4, 2 and 2. We know that the product needs to add up to our middle term, which is positive 4x. Anyone know what terms we're going to use? Yes, 2 and 2. So, our factored form, we have 1. We're going to put our 2 brackets here. Okay? The x's are the first terms in each bracket, and it just so happens we're going to be using positive 2. So if you notice, both of the brackets are the exact same, and that's what a perfect square trinomial is. When we factor it, our brackets are the same, so we can represent them as a bracket squared. Okay? So, we're now going to represent this bracket as x plus 2 squared. And we're going to evaluate negative 4 and 16. What's negative 4 plus 16? That's right. Now, we're going to zoom out a little here. I want you guys to make the connection. If you guys notice, what form are we in right now? We're in vertex form right now. So, with the information we have down here, we've just moved from standard, which was here, to our vertex form. Completing the square was many steps in this case. I'm going to gather some information. So, in standard form, the only thing we could really tell was that our y-intercept was going to be 16. We know that the c-value is our y-intercept. Let's zoom in so we can read this. Our vertex form. What is our vertex here now? Negative 2 and positive 12. That's what completing the square allowed us to do. We don't have to factor before we do it. Okay.